Do the pyramids of Giza prove a civilization survived the Great Floods? They rise from the desert plateau at the edge of modern Cairo, three massive structures of limestone and granite that have dominated the landscape for millennia. The Great Pyramid of Giza, along with its companions, represents the pinnacle of what we are told was early human architectural achievement, built around 2500 BCE by Pharaoh Khufu and his successors during Egypt's fourth dynasty. According to Orthodox Egyptology, these pyramids were constructed by a civilization that had only recently emerged from the Stone Age, using copper tools, wooden sledges, and vast armies of workers organized by bureaucratic genius. The precision with which they were built aligned to true north within a fraction of a degree, constructed with blocks weighing up to 70 tons, fitted so perfectly that a razor blade cannot slip between them, incorporating mathematical constants that would not be discovered for thousands of years. All of this, we are told, was accomplished by trial and error, by incremental development from simpler structures, by human ingenuity applied over decades of labor. Yet when you stand before these monuments and confront their scale, their precision, their inexplicable perfection, a question forms that refuses to be silenced. How? How did a civilization that left no record of development, no evidence of failed experiments, no intermediate stages showing gradual improvement, suddenly produce the most precisely constructed buildings in the ancient world? And more troubling still, why? Why would a Bronze Age society invest resources equivalent to decades of national wealth to build structures whose purpose remains disputed, whose internal chambers seem almost an afterthought, whose design incorporates knowledge of astronomy, geodesy, and mathematics that supposedly did not exist when they were built? The orthodox answer has remained essentially unchanged. For over a century, these were tombs, monuments to royal vanity, products of a society that happened to reach its architectural peak at its very beginning and then declined. But an alternative explanation has gained traction among researchers willing to question established timelines. What if the pyramids were not the beginning, but the culmination? What if they represent not the first flowering of Egyptian civilization, but the last achievement of something older, something that survived a global catastrophe and left these monuments as testament to knowledge that preceded the flood? Tonight, we examine the evidence that has led some researchers to propose that the pyramids of Giza, far from being products of the early 4th dynasty, might be structures built by or with knowledge from a civilization that survived the great floods described in myths worldwide, a civilization whose existence orthodox archaeology denies, but whose fingerprints might be preserved in stone on the Giza plateau. This is, do the pyramids of Giza prove a civilization survived the great floods? The precision that shouldn't exist. The first thing that strikes anyone who seriously examines the Great Pyramid is not its size, though at 481 feet tall and covering 13 acres, it is certainly massive, but its precision. This is not rough megalithic construction where approximate positioning was good enough. This is engineering that meets or exceeds modern standards, executed in materials that are extraordinarily difficult to work with, on a scale that strains credibility even with modern technology. The base of the Great Pyramid is level to within less than an inch across its 756-foot length. This means the foundation was surveyed and leveled with an accuracy of 0.1%, a feat that would be impressive with modern laser levels and is essentially inexplicable with the tools that supposedly existed in 2500 BCE. The four sides of the base are aligned to true north, south, east, and west, with an average error of only 3 arc minutes less than 1/15 of a degree. This alignment is so precise that it has been used by modern surveyors to check their instruments. The construction itself demonstrates similar precision. The pyramid contains approximately 2.3 million blocks of limestone and granite, each weighing between 2.5 and 70 tons. These blocks are fitted together so precisely that mortar was unnecessary to the structural integrity. The mortar that does exist was used primarily to facilitate sliding blocks into position, not to hold them together. The joints between blocks are so tight that they conform to tolerances of 1/50 of an inch, tighter than most modern construction. Some joints are so perfect that they cannot be replicated today without advanced machinery. Inside the pyramid, the precision continues. The so-called King's Chamber is constructed from massive granite blocks weighing up to 70 tons each, transported from quarries at Aswan over 500 miles away. The chamber's dimensions form perfect geometric relationships. Its length is exactly twice its width, and its height completes a proportion known as the golden ratio, or phi, which appears repeatedly in nature and which wasn't formally described in mathematics until the ancient Greeks. The granite blocks forming the ceiling are cut so precisely and fitted so perfectly that the chamber has supported millions of tons of overlying stone for millennia without sagging, cracking, or requiring maintenance. The passages within the pyramid are aligned with similar precision. The descending passage points directly at the position where the star Thuban, the pole star in 2500 BCE, would have been visible in the night sky. The ascending passage points toward where Alcyone, the brightest star in the Pleiades, would have transited. Whether these alignments are coincidental or intentional, they demonstrate a level of surveying accuracy that required sophisticated understanding of astronomy and an ability to translate celestial observations into terrestrial construction with extraordinary precision. Perhaps most troubling for conventional explanations is the mathematical sophistication embedded in the pyramid's proportions. The ratio of the pyramid's perimeter to its height is 2 pi, the same ratio as the circumference of a circle to its radius. This means the pyramid encodes the mathematical constant pi to an accuracy that would not be achieved in written mathematics until Greek civilization, 2,000 years after the pyramid was supposedly built. The slope of the pyramid's sides produces an angle whose tangent equals phi, the golden ratio, suggesting the builders understood this mathematical relationship as well. Orthodox Egyptologists explain this precision as the result of skilled craftsmanship, careful planning, and abundant labor. They point to evidence of quarries, tool marks on stones, and administrative papyri describing worker rations and organization as proof that the pyramids were built by conventional means. They argue that the mathematical relationships are either coincidental or demonstrate that ancient Egyptians were more sophisticated than generally credited, that they empirically discovered mathematical relationships without formal mathematics, using practical techniques refined through centuries of building smaller structures. But alternative researchers note several problems with this explanation. First, if the precision resulted from gradual development, we should see a progression earlier. Structures should show less precision, with accuracy improving over time. Instead, the opposite is true. The Great Pyramid demonstrates the highest precision of any structure in Egypt. Later, pyramids and temples, built when Egyptian civilization was supposedly more advanced, show less precision cruder construction, and more evidence of trial and error. This is the reverse of what evolutionary development would produce. Second, the conventional timeline provides no time for this development. Egyptian civilization supposedly emerged around 3100 BCE with the unification of Upper and Lower Egypt. The Great Pyramid was supposedly built around 2560 BCE, only 540 years later. This means Egyptian civilization went from the late Stone Age to producing the most precisely constructed building in the ancient world in just over 5 centuries, then never matched that achievement again. For comparison, European civilization took over 1,000 years from the fall of Rome to produce Gothic cathedrals, which are far less precisely constructed than the Great Pyramid. Third, there are no developmental stages preserved. We should find failed pyramids, experimental structures, prototypes showing trial and error. While Egyptologists point to earlier pyramids and mastabas as precursors, none demonstrate the precision of Giza. It is as if the knowledge of how to build with such accuracy appeared fully formed, was used for a brief period, and then was lost or abandoned. This patterned sudden appearance of maximum sophistication, followed by decline, is characteristic not of invention, but of inheritance. When a civilization inherits advanced knowledge from predecessors, it may be able to apply that knowledge without fully understanding underlying principles. Over time, as the inherited knowledge is imperfectly passed down through generations, the ability to replicate original achievements degrades. This would explain why the earliest large-scale Egyptian constructions are the most sophisticated, why later builders could not match their precision, and why even the Egyptians themselves seem to regard the pyramids with awe, attributing them to gods or to ancestors with capabilities modern Egyptians did not possess. If the precision of the pyramids reflects inherited knowledge rather than indigenous development, the question becomes, inherited from whom? Orthodox archaeology insists no advanced civilization existed before the Egyptians in this region. But if the pyramids preserve evidence of knowledge that predates conventional Egyptian civilization, then that knowledge had to come from somewhere, from some group that possessed sophisticated understanding of mathematics, astronomy, and engineering before 2500 BCE, and that transmitted this knowledge to the pyramid builders. The dating problem. Orthodox chronology places the construction of the Great Pyramid during the reign of Pharaoh Khufu around 2560 BCE, based primarily on evidence that has come under increasing scrutiny in recent decades. This dating relies heavily on 3 sources. The cartouche bearing Khufu's name, found in a relieving chamber above the king's chamber, radiocarbon dating of organic materials found in the mortar, and historical records from later Egyptian periods attributing the pyramid to Khufu. Each of these evidence sources has significant problems. The cartouche, discovered by Colonel Howard Vyse in 1837, has been questioned by some researchers who note irregularities in its execution compared to other hieroglyphs of that period. The paint appears to have been applied hastily and contains grammatical errors that would be unlikely in official inscriptions. Some critics have suggested, controversially, that Vyse may have forged the cartouche to support his patron's theories about pyramid dating, though this accusation remains disputed and has not been proven. The radiocarbon dating is more complex. Multiple radiocarbon studies have been conducted on organic materials, charcoal, mortar, and wood found in various pyramids. The results have been inconsistent and often problematic. Some samples dated to periods before the pyramids were supposedly built. Others dated to periods centuries after. When samples from the same pyramid were tested by different laboratories, results varied by hundreds of years. The most extensive study, conducted in the 1980s, found that organic materials in the Great Pyramid averaged about 374 years older than the historical dating would predict, meaning the materials dated to around 2900 BCE rather than 2560 BCE. Egyptologists explain this discrepancy by suggesting the Egyptians used old wood timber from trees that had died centuries earlier in pyramid construction. This is plausible. Ancient wood was valuable in timber-scarce Egypt, and reusing old wood from earlier structures or long-dead trees would be logical. However, this explanation creates uncertainty about what the radiocarbon dates actually represent: the age of the wood or the date of pyramid construction. If old wood can explain dates that are too early, then radiocarbon dating cannot definitively establish when the pyramids were built. The historical records are equally problematic. The first Egyptian writer to explicitly attribute the Great Pyramid to Khufu was Herodotus, the Greek historian who visited Egypt around 450 BCE, over 2,000 years after Khufu supposedly lived. Herodotus reported what Egyptian priests told him, but his account contains numerous errors and fantastical elements that Egyptologists acknowledge are unreliable. Later classical writers, including Diodorus, Siculus, and Pliny the Elder, also attributed the pyramids to various pharaohs, but their accounts disagree with each other and with Herodotus, suggesting these were traditions and legends rather than preserved historical records. Egyptian records from the Pyramid Age itself are curiously silent about pyramid construction. We have extensive administrative documents from the Old Kingdom describing worker rations, tool distributions, and logistical organization, but no text explicitly describes building the Great Pyramid. The pyramid texts, religious inscriptions found in later pyramids, mention pyramids but do not describe their construction. The absence of contemporary documents describing what would have been the greatest construction project in Egyptian history is strange and has led some researchers to question whether the pyramids were actually built during the reigns traditionally assigned to them. This uncertainty about dating opens the possibility that the pyramids are older, perhaps much older, than orthodox chronology allows. If the radiocarbon dates showing older ages are accurate, if the attribution to Khufu is mistaken tradition rather than historical fact, then the pyramids could predate established Egyptian civilization. They could have been built during an earlier period, about which we know little, a period that coincides with the end of the last ice age, with the global flooding events described in myths worldwide, with the catastrophic climate changes that transformed the Near East from green savanna into desert. Alternative researchers point to geological evidence suggesting the Giza plateau experienced very different climate conditions in the past. The Sphinx and its enclosure show patterns of weathering that some geologists interpret as water erosion rather than wind and sand erosion. If this interpretation is correct, it would mean the Sphinx was exposed to substantial rainfall for prolonged periods, conditions that did not exist in Egypt after about 3000 BCE, when the region became predominantly arid. This would push the date of the Sphinx and potentially the pyramids back to a period when the Sahara was still green, when rivers flowed where only sand exists now, when the climate was fundamentally different from historical Egypt. The conventional response is that the weathering patterns can be explained by other mechanisms: groundwater seepage, chemical weathering, sand abrasion, and that pushing dates back thousands of years conflicts with the entire archaeological record of human development in the region. There is no evidence for an advanced civilization capable of pyramid building in Egypt before 3100 BCE, and extraordinary claims require extraordinary evidence. But the dating problem persists. If the pyramids were built when orthodox chronology claims, using the tools and techniques that supposedly existed then by a civilization that had only recently emerged from prehistory, then their precision, their scale, their mathematical sophistication represent an anomaly that standard developmental models struggle to explain. If they are older, if they were built during or after a catastrophic period that disrupted earlier civilizations, if they represent the preservation or restoration of older knowledge, then many of their anomalous features become more comprehensible. The question is not whether the pyramids are old, clearly they are ancient, but whether they are as old as we assume, and whether the civilization that built them was the first to inhabit the Giza plateau, or merely the first that we recognize. The flood that changed everything. The story of a great flood that destroyed an earlier world is not unique to Genesis. It appears in Mesopotamian texts like the Epic of Gilgamesh and the Atrahasis, in Greek mythology, in Hindu scriptures, in Chinese legends, in Native American traditions, in Aboriginal Australian stories, in Polynesian myths. The specific details vary: the cause of the flood, who was warned, how survivors escaped. But the core narrative is remarkably consistent. A catastrophic deluge destroyed the world as it existed, wiping out most of humanity and all civilization, with only a few survivors preserving knowledge of what came before. For centuries, these flood stories were dismissed as either exaggerated memories of local flooding events or as pure mythology with no basis in historical reality. But geological and archaeological evidence accumulated over the last century has made it increasingly clear that the end of the last ice age, between approximately 11,600 and 8,000 years ago, was marked by catastrophic climate change, dramatic sea level rise, and flooding on scales that dwarf anything in recorded history. During the Ice Age, massive ice sheets covered much of North America and Europe, locking up enormous quantities of water. Sea levels were approximately 400 feet lower than present, exposing vast areas of continental shelf that are now submerged. The coastlines were dramatically different. The Persian Gulf was dry land, the Mediterranean was smaller. Land bridges existed between continents that are now separated by water. Human populations naturally concentrated in coastal areas and river valleys where resources were abundant. When the Ice Age ended, the ice sheets melted, releasing water that had been locked up for tens of thousands of years. This was not a gradual process, but occurred in pulses, with periods of relatively stable sea level interrupted by episodes of catastrophic melting and rapid rise. The most dramatic event, called Meltwater Pulse 1A, occurred around 14,600 years ago and raised global sea levels by approximately 50 feet in less than 500 years and possibly much faster, with some estimates suggesting rises of 16 to 20 feet per century during peak melting phases. The impact on human populations would have been devastating. Coastal settlements, river valleys, and low-lying plains where people lived would have been inundated. The rate of sea level rise several inches to feet per year during peak periods would have been perceptible within human lifetimes, forcing repeated migrations inland. Over generations, entire landscapes would vanish beneath the waves. The archaeological evidence of early human settlements, trade networks, and potentially complex societies that existed on these now submerged lands is largely inaccessible, preserved only where it extended onto higher ground, or where unusual circumstances prevented its complete destruction. This global flooding coincides with other catastrophic changes. The African humid period, when the Sahara was green savanna with rivers and lakes, ended around 5,000 to 6,000 years ago, transforming a fertile region into desert. The Black Sea was a freshwater lake until around 5,600 BCE, when rising Mediterranean sea levels breached natural barriers and salt water catastrophically flooded the basin, expanding the Black Sea to its present size and inundating thousands of square miles of inhabited land. Similar flooding events occurred worldwide as Ice Age geography transformed into the modern world. The significance for understanding the pyramids is this: if advanced civilizations existed before these floods, their remains would be difficult to find. Coastal cities would be under hundreds of feet of water. Settlements in regions that became desert would be buried under sand. The archaeological signature of pre-flood civilization would be fragmentary, controversial, and easily dismissed, exactly what we observe when examining evidence that doesn't fit conventional timelines. The flood myths themselves may preserve memory of these events. When the myths describe a world before the flood that was different from the world after, they may be accurately recording the end of the Ice Age. When they describe survivors who preserved knowledge from the old world and brought it to the new, they may be describing the transmission of information across the catastrophic boundary. When they describe civilization beginning after the flood, they may be marking not the origin of human culture, but its reconstitution after near total disruption. Egypt's position in this framework is potentially significant. The Nile Valley would have been affected, but not destroyed by sea level rise. The river drains into the Mediterranean, and while delta regions would have been inundated, the valley itself remained habitable. Egypt could have served as refuge for populations displaced from submerged coastal regions, from the drying Sahara, from disrupted Near Eastern centers. These refugees might have brought knowledge with them, knowledge of astronomy, mathematics, engineering, preserved from pre-flood civilizations and adapted to post-flood conditions. If this scenario has any basis in reality, we would expect to find evidence of sudden appearance of sophisticated knowledge in Egypt without clear developmental precursors, exactly what the pyramids represent. We would expect this knowledge to appear shortly after the catastrophic period, and 2500 BCE, the conventional date for pyramid construction, is well within the time frame of post-flood recovery. We would expect the knowledge to be imperfectly understood and imperfectly applied, and the fact that pyramid precision was never matched in later Egyptian construction suggests the builders were working with inherited knowledge. They did not fully comprehend. The flood that changed everything may have done more than destroy an earlier world. It may have created conditions where knowledge from that earlier world could be preserved, transmitted, and eventually expressed in stone on the Giza plateau. Whether this scenario is plausible depends on whether evidence exists in the pyramids themselves, in their alignments, in their construction, in their location that points to inheritance from a pre-flood civilization. That is the question we must examine. The watermarks. If the pyramids or structures associated with them were built before or during the catastrophic flooding at the end of the Ice Age, there should be geological evidence marks left by water exposure that conventional dating cannot explain. The most controversial such evidence centers not on the pyramids themselves, but on the Great Sphinx, which stands on the Giza plateau near the pyramids, and which some researchers argue shows clear signs of water erosion inconsistent with its conventional dating. The Sphinx is carved from limestone bedrock, with its body and enclosure excavated from the plateau itself. According to Orthodox chronology, it was carved during the reign of Pharaoh Khufu around 2500 BCE, at the same time as the Second Pyramid. This dating is based on stylistic analysis of the Sphinx's face, which Egyptologists believe represents Khafre, and on the assumption that the Sphinx Temple and Valley Temple, which are architecturally similar to structures associated with Khafre's pyramid, were all built as part of the same construction program. In 1990, Dr. Robert Schoch, a geologist from Boston University, examined the Sphinx and its enclosure and concluded that the weathering patterns visible on the limestone walls were caused primarily by water erosion rather than by wind and sand abrasion. Schoch noted that the erosion is vertical and wave-like, cutting deep fissures into the limestone, a pattern characteristic of rainfall runoff rather than horizontal wind erosion. The enclosure walls show this weathering pattern most dramatically, with the upper portions more heavily eroded than lower portions, suggesting prolonged exposure to rain falling from above. The significance of this observation is that Egypt has been predominantly arid for the past 4,500 to 5,000 years. If the Sphinx was carved around 2500 BCE, it would not have been exposed to sufficient rainfall to produce the observed erosion patterns. The region receives minimal rainfall today and has received minimal rainfall throughout the historical period. However, during the African humid period, which lasted until approximately 3000 to 3500 BCE, the Sahara and North Africa experienced monsoon rains and supported abundant vegetation. Before that, conditions were even wetter during parts of the last ice age. If Schoch's interpretation of the erosion is correct, the Sphinx must have been carved during or before the humid period, potentially pushing its origin back to 5000 BCE or earlier, thousands of years before conventional Egyptian civilization. This would make the Sphinx older than the civilization that supposedly carved it, suggesting either that dating is wrong or that some earlier culture created the Sphinx and later Egyptians merely restored or modified it. Orthodox Egyptologists have vigorously disputed Schoch's conclusions. They argue that the weathering patterns can be explained by other mechanisms: chemical weathering accelerated by morning dew, subsurface moisture wicking through porous limestone, wind-blown sand mixed with moisture, or natural exfoliation of limestone layers. They point out that other structures in Egypt with similar limestone composition and supposedly similar age do not show the same weathering patterns Schoch identified, suggesting local geological conditions rather than rainfall are responsible. Schoch and supporting geologists respond that these alternative explanations do not adequately account for the specific characteristics of the erosion, the vertical patterns, the differential weathering between upper and lower enclosure walls, the comparison with other limestone structures in Egypt that show different weathering patterns because they were not carved from below-ground bedrock but built with quarried blocks. They maintain that the most parsimonious explanation remains water erosion from sustained rainfall. The debate has remained unresolved for over 30 years, with geologists and Egyptologists taking opposing positions based on different interpretations of the same evidence. What is clear is that if Schoch is correct, the implications extend beyond the Sphinx itself. The Sphinx Temple and Valley Temple, built from enormous limestone blocks weighing up to 200 tons, some of the largest blocks moved in ancient Egypt, sit directly adjacent to the Sphinx and show similar erosion patterns. If the Sphinx is older than conventional dating allows, these temples might be as well. And if structures on the Giza plateau predate conventional Egyptian civilization, the pyramid's relationship to that earlier construction becomes questionable. Some researchers have suggested that the entire Giza complex might represent multiple construction phases spanning thousands of years. Perhaps an earlier civilization carved the Sphinx and built the temples during the humid period. Perhaps they also began the pyramids, or at least surveyed and prepared the plateau for construction. Perhaps later, around 2500 BCE, the early Egyptians completed or refurbished these structures, adding their own modifications and improvements. This would explain why the pyramids show characteristics of both primitive and advanced construction, why some passages are crude while others are precise, why some stones are roughly placed while others are perfectly fitted, why the internal chambers seem almost carelessly designed, despite the external structure's geometric perfection. The water erosion argument remains controversial and is rejected by most mainstream archaeologists, but it represents the type of physical evidence that should exist if a pre-flood or end-of-flood period civilization built structures on the Giza plateau. The fact that the evidence is ambiguous enough to generate decades of academic debate rather than being definitively resolved in favor of conventional explanations keeps the question open and suggests that orthodox dating may be incomplete even if not entirely wrong. The knowledge that couldn't exist. Beyond the precision of construction and the dating controversies, the pyramids embody knowledge that, according to conventional understanding of history, should not have existed when they were built. This knowledge spans multiple disciplines: astronomy, geodesy, mathematics, and physics, and its presence in structures supposedly erected by a civilization that had only recently emerged from the Stone Age presents a paradox that conventional explanations struggle to resolve. The astronomical alignments of the pyramids are the most obvious example. The three main pyramids at Giza are positioned in a pattern that closely matches the three stars in Orion's belt. The correlation is not perfect, there are slight offsets, but the overall pattern is unmistakable, with the relative sizes and positions of the pyramids corresponding to the relative brightnesses and positions of Alnitak, Al-Nilam, and Mintaka, the three belt stars. The air shafts from the King's Chamber point toward specific stars. The southern shaft toward Alnitak in Orion's belt. The northern shaft toward Thuban. The pole star in 2500 BCE. Orthodox Egyptology explains these alignments as evidence of Egyptian religious beliefs about the afterlife and the pharaoh's journey to the stars. The pyramid texts, inscribed in later pyramids, describe the deceased pharaoh ascending to the sky and becoming a star. Aligning pyramids and passages towards specific stars would facilitate this spiritual journey. This religious explanation is reasonable and consistent with known Egyptian beliefs. But alternative researchers note that the alignments demonstrate sophisticated astronomical knowledge that required extensive observation and precise mathematical calculation. Identifying the pole star required understanding of precession, the slow wobble of Earth's axis that causes different stars to serve as pole star over millennia. Achieving alignment to within 3 arc minutes required not just knowing where the pole star was, but being able to measure angles with extraordinary precision. The Orion correlation, if intentional, required recognizing a 3-dimensional pattern of stars and translating it into 2-dimensional ground positioning, with correct scale and orientation, not a simple observational feat. More troubling is that no evidence exists of the centuries of astronomical observation that would have been necessary to develop this knowledge. We find no Egyptian records of systematic star catalogues, no astronomical observatories, no descriptions of instruments used to measure celestial positions with such precision. The knowledge appears fully formed in the pyramids, without developmental precursors, suggesting either that the entire observational period has left no archaeological trace, or that the knowledge was inherited from earlier observers. The geodetic knowledge encoded in the pyramids is even more problematic. The Great Pyramid sits almost exactly at the center of Earth's landmass. Its location at 29.9792 degrees N latitude is remarkably close to the speed of light in meters per second, 299,792,458 ms, which some researchers note as an interesting coincidence. More significantly, the pyramid's dimensions encode precise geodetic information. The ratio of its perimeter to its height equals the ratio of Earth's circumference to its radius, meaning the pyramid is a scale model of Earth's northern hemisphere at a ratio of 1:43,200. If this is coincidence, it is extraordinary. If it is intentional, it means the pyramid builders knew Earth's size and shape with accuracy not achieved again until satellites allowed precise measurement in the 20th century. Orthodox explanations suggest either coincidence or that the builders empirically discovered these ratios without understanding their geodetic significance, that they were building to aesthetically pleasing proportions that happened to match Earth's geometry. The mathematical knowledge is similarly advanced. The pyramid encodes pi, the ratio of circumference to diameter, in the ratio of its perimeter to twice its height. It encodes phi, the golden ratio, in the ratio of its slant height to half its base. These mathematical constants appear repeatedly in nature and were considered profound discoveries when ancient Greek mathematicians described them formally. If the pyramid builders deliberately incorporated pi and phi, they possessed mathematical knowledge that supposedly didn't exist for 2,000 more years. If these ratios emerged naturally from construction methods, it suggests those construction methods were based on geometric principles so sophisticated that they produced optimal ratios without conscious mathematical analysis, which is itself remarkable. The physics of pyramid construction also presents challenges. Moving 2.3 million blocks, averaging 2.5 tons each, with some weighing up to 70 tons, over a 20-year construction period, the time span traditional table lie attributed to the Great Pyramid's construction requires placing one block every 2 minutes for 10 hours per day, 7 days per week, for 2 decades. This assumes perfect organization, no delays, no mistakes, and continuous work regardless of weather, Nile flooding, or other disruptions. The quarrying, transport, and precise positioning of 70-ton granite blocks from Aswan, 500 miles away, presents even greater challenges. Orthodox explanations invoke large workforces, sophisticated organization, and clever engineering techniques, ramps, sledges, levers, lubricants, all of which are plausible in isolation, but which together create a logistical challenge that strains credibility. No definitive evidence exists for the massive ramps that would have been necessary to raise blocks to upper pyramid levels. Such ramps would have required as much material as the pyramid itself, and would have left substantial archaeological traces, yet no certain examples have been found. Alternative researchers suggest that the knowledge necessary for pyramid construction, the astronomical observations, the geodetic measurements, the mathematical proportions, the engineering techniques represents inherited wisdom from an earlier civilization that possessed this knowledge and transmitted it forward. This would explain why the knowledge appears suddenly and fully formed, why it was imperfectly understood by those who applied it, hence the inconsistencies and mistakes present in the construction, and why it degraded over time as transmission across generations inevitably loses information. The question is whether any evidence exists for such a predecessor civilization. Orthodox archaeology says no, there is no physical evidence for an advanced civilization in Egypt or elsewhere that predates the early Egyptians and that could have transmitted this knowledge. Alternative researchers point to anomalous archaeological sites worldwide that conventional dating cannot explain, to myths that consistently describe advanced predecessors destroyed by catastrophe, and to the pyramids themselves as evidence of knowledge that has no other satisfactory explanation. The debate over knowledge inheritance remains unresolved because it touches fundamental questions about human development, about whether civilization progresses linearly or experiences cycles of rise and fall, and about whether the archaeological record is complete enough to rule out earlier advanced cultures. What is clear is that the knowledge embodied in the pyramids, whether indigenous or inherited, represents an extraordinary achievement that continues to challenge our understanding of ancient capabilities. The astronomical clock. One of the most intriguing aspects of the Giza pyramids is how their alignments and orientations might encode astronomical information spanning vast time periods. Information that has led some researchers to propose that the pyramids function as a kind of astronomical clock, marking specific moments in Earth's precessional cycle and potentially pointing to periods far earlier than conventional dating allows. Precession is the slow wobble of Earth's axis over a cycle of approximately 25,920 years. This wobble causes the position of stars relative to Earth's equator and poles to shift slowly over millennia. The consequence is that different stars serve as pole stars at different epochs, and the position where the sun rises on the equinox moves backward through the zodiac constellations, taking about 2,160 years to move through each constellation, hence the Age of Aquarius, Age of Pisces, and so forth. The ancient Egyptians knew about precession, or at least observed its effects. But our written record of precession begins with the Greek astronomer Hipparchus around 130 BCE, about 2,400 years after the pyramids were supposedly built. For the pyramid builders to incorporate precessional information into their design, they would have needed to observe the night sky carefully enough and for long enough to notice the extremely slow drift of stellar positions, an observation program spanning centuries, potentially millennia. Researcher Robert Bauval noted that while the three Giza pyramids match the pattern of Orion's belt stars as they appeared in Egyptian skies around 2500 BCE, the match is not perfect. The alignment is slightly rotated from the precise Orion pattern, but if you use astronomical software to calculate how Orion appeared at different epochs, moving backward through time due to precession, There is one date when Orion's belt aligns perfectly with the ground plan of the pyramids, 10,500 BCE. At that date, Orion was at its lowest point in its precessional cycle, at first time, in the Egyptian mythological sense, the beginning of a new cycle. This date also coincides with the moment when the Sphinx, looking due east, would have gazed directly at its celestial counterpart, the constellation Leo, rising on the spring equinox, a correlation that has led some researchers to propose that the entire Giza complex was designed to commemorate or mark that specific epoch. Orthodox Egyptologists dismiss this correlation as coincidental or as selectively focusing on one moment in precession while ignoring thousands of other dates that would produce different alignments. They point out that finding meaningful alignments with ancient structures is relatively easy because the night sky contains hundreds of bright stars, and any sufficiently complex structure will align with some of them at some dates. They also note that attributing religious or astronomical significance to 10,500 BCE requires accepting that the pyramids were either built at that date, impossible given all archaeological evidence, or that builders in 2500 BCE had accurate astronomical records extending back 8,000 years. Implausible given the lack of any evidence for such records. But alternative researchers argue that the 10,500 BCE date appears in multiple independent lines of evidence: the Orion correlation, the Leo-Sphinx correlation, the possible water erosion dating of the Sphinx, and that this convergence is unlikely to be purely coincidental. They propose that even if the pyramids were physically built around 2500 BCE, their design was based on knowledge or instructions preserved from the earlier epoch, possibly marking it as significant for astronomical, religious, or commemorative reasons. The concept of astronomical cycles was central to ancient thought across many cultures. The idea that time moved in great cycles, that civilizations rose and fell in rhythm with celestial movements, that specific astronomical moments marked transitions between world ages. These ideas appear in Hindu cosmology, Mayan calendars, Greek philosophy, and Egyptian religion. If the pyramids encode astronomical information pointing to 10,500 BCE, they might be marking the end of one world age and the beginning of another specifically. The end of the Ice Age and the catastrophic flooding that accompanied it. The event that separated the old world from the new world. This interpretation suggests the pyramids serve not just as tombs or temples, but as monuments marking the transition between ages, as memorials to knowledge from before the flood, as markers ensuring that future generations would recognize the significance of this epoch and understand that civilization had existed before the catastrophe. In this reading, the pyramids are simultaneously ancient, built 4,500 years ago, and far more ancient, encoding information from 12,500 years ago, built by the early Egyptians, but preserving the astronomical knowledge of their pre-flood predecessors. The astronomical clock hypothesis remains speculative and controversial, but it raises a testable question. If structures were deliberately designed to mark a specific astronomical epoch, what would we expect to find? We would expect precise alignments with stars as they appeared at that epoch. We would expect geometric relationships encoding astronomical information. We would expect religious or mythological texts associating the structures with that epoch. And we would expect knowledge of precession and long-term astronomical cycles. The pyramids demonstrate the first three characteristics. Whether they demonstrate the fourth knowledge of precession remains disputed. But the fact that such knowledge could be encoded in stone, preserved for millennia, and recovered by modern astronomers using computers to reconstruct ancient skies, suggests that if an earlier civilization wanted to leave a message about when they existed or when some significant event occurred, building massive, precisely aligned structures would be an effective method. Stone lasts, writing fades, languages die, but astronomical alignments can be read by anyone with sufficient understanding of celestial mechanics, regardless of what language they speak or what culture they belong to. The global pattern. If the evidence from Giza stood alone, it might be dismissed as anomalous but not definitive. But when examined in the context of similar enigmas at archaeological sites worldwide, a pattern emerges, a pattern of sophisticated ancient construction that appears suddenly in the archaeological record, demonstrates knowledge that supposedly didn't exist, and is associated with flood myths describing earlier civilizations destroyed by catastrophe. Göbekli Tepe in Turkey, dated to approximately 9,500 BCE through radiocarbon dating, predates the invention of agriculture, pottery, and settled civilization by thousands of years. Yet it consists of massive T-shaped limestone pillars weighing up to 20 tons, elaborately carved with sophisticated imagery, arranged in circular enclosures that required extensive planning and organized labor. According to conventional understanding of human development, hunter-gatherers at this time should not have been capable of such construction. Yet, there it stands, definitively dated, impossible to dismiss. And it was deliberately buried around 8,000 BCE, entombed intentionally by its builders or their successors, preserved beneath earthen fill for 10,000 years. Göbekli Tepe's date is significant because it places sophisticated construction firmly in the pre-flood period built during the time when ice sheets were melting and sea levels were rising catastrophically. The decision to bury it corresponds roughly with the end of major flooding and the beginning of the Holocene, the current geological epoch. This could be coincidence, or it could indicate that Göbekli Tepe represents the end of a cultural tradition that did not survive the climatic catastrophe. In Peru, the site of Sacsayhuaman near Cusco features megalithic walls built from stones weighing over 100 tons, fitted together so precisely that mortar was unnecessary and joints are too tight to insert paper. The construction technique is identical to that seen at Giza: massive stones, precise fitting, unexplained engineering. Orthodox archaeology attributes Sacsayhuaman to the Inca civilization around 1400 to 1500 CE. But Inca legends state that the site was already ancient when their civilization began, built by earlier peoples whose capabilities exceeded the Inca themselves. At Tiwanaku in Bolivia, structures include stones weighing up to 400 tons transported from quarries miles away, astronomical alignments suggesting construction around 15,000 BCE based on stellar precession calculations, and evidence of advanced stoneworking techniques that leave machine tool-like precision cuts on andesite, one of the hardest stones. Orthodox dating places Tiwanaku's construction around 300 to 500 CE, but geological evidence suggests the site may have been a port on Lake Titicaca when water levels were much higher conditions that existed during late Ice Age periods, not in historical times. In Egypt itself, the Osiraion at Abydos demonstrates construction technique radically different from other Egyptian structures. It is built from massive granite and limestone blocks, some weighing over 100 tons, fitted together without mortar, using only precise cutting and placement. The blocks show no tool marks from copper or bronze implements. The cuts are clean and precise, in a manner suggesting advanced metallurgy. Orthodox dating places it in the reign of Seti I around 1300 BCE, but the construction technique more closely resembles the Sphinx temples, which may be far older. At Baalbek in Lebanon, the Temple of Jupiter sits on a platform of truly enormous stones, the trilithon, 3 limestone blocks each, weighing approximately 800 tons. Beneath these are even larger blocks, including one that weighs approximately 1,200 tons, and remains partly quarried from bedrock nearby. These are among the largest stones ever moved by humans, and exactly how they were transported and lifted into position remains unexplained. Roman construction sits atop far more ancient foundations, and local legends attribute the oldest construction to giants or to civilizations before the flood. This global pattern, massive megalithic construction, precise stoneworking, sophisticated astronomy, sudden appearance of advanced techniques, local legends of pre-flood builders, appears on every continent except Antarctica. The structures are separated by oceans and thousands of miles, yet they share characteristics that suggest either independent development of similar advanced techniques, implausible given the lack of developmental precursors at each site, or diffusion of knowledge from a common source, which would require accepting that global communication existed in prehistory, or inheritance from a preceding global civilization, which conventional archaeology denies existed. Alternative researchers point to this global pattern as evidence of exactly what flood myths describe: a worldwide civilization possessing advanced knowledge that was destroyed by catastrophe, with survivors spreading to different regions and attempting to reconstruct what was lost. The megalithic sites represent the greatest achievements of these survivors, or their immediate descendants, built using inherited knowledge that was imperfectly understood and progressively lost over subsequent generations, as oral transmission degraded and the original source was forgotten. Orthodox archaeology explains the global similarities through universal human patterns. People everywhere develop similar solutions to similar problems, build monuments to honor gods and rulers, observe the sky to track seasons, and tell flood stories, because flooding is a universal human experience. The apparent sophistication of ancient construction is explained by assuming ancient peoples were more capable than generally credited, that they had adequate time and resources, and that they employed clever techniques that left no archaeological trace, because those techniques used perishable materials or knowledge that was never written down. The debate remains unresolved because it touches fundamental questions about human prehistory, about whether civilization developed once in a linear progression, or multiple times following cycles of rise and fall, and about whether apparent convergence in ancient knowledge and techniques indicates diffusion from a common source or independent parallel development. What is clear is that Giza is not unique, it is part of a worldwide pattern of problematic ancient construction that challenges standard narratives and that continues to generate theories seeking to explain how these structures built, by whom, and whether their builders were the first advanced humans or inheritors of knowledge from predecessors destroyed by flood. The orthodox response. Mainstream Egyptology and archaeology have responded to alternative theories about the pyramid's origins with a mix of detailed rebuttal, dismissal as pseudoscience, and acknowledgement that some questions remain unanswered. The orthodox position, refined over more than a century of research, rests on several foundational claims that form a comprehensive explanation for the pyramids as products of 4th Dynasty Egypt. First, developmental progression. Egyptologists point to clear architectural evolution from simple mastaba tombs through step pyramids to the true pyramids at Giza. The Pyramid of Djoser at Saqqara, built around 2650 BCE, was the first large stone structure in Egypt, a step pyramid created by stacking progressively smaller mastabas. The pyramids at Medum and Dashur show experimental designs. The bent pyramid has 2 different angles, suggesting the builders recognized structural problems mid-construction and adapted their design. Only after these experiments did the builders achieve the true pyramid form at Giza. This progression demonstrates trial and error, gradual improvement, and learning from mistakes, exactly what evolutionary development predicts. Second, extensive documentation. While no text explicitly describes building the Great Pyramid, extensive documentation exists from the Pyramid Age describing quarrying, transport, worker organization, rations, tools, and administrative oversight. The Diary of Mera, a papyrus discovered in 2013, describes transporting limestone blocks to Giza during Khufu's reign, proving that large-scale construction was occurring exactly when conventional chronology places pyramid construction. Quarries at Aswan show tool marks from copper chisels, demonstrating that the Egyptians possessed the tools and knowledge necessary for stoneworking, even if the process was labor-intensive and time-consuming. Third, burial function. The pyramids consistently contain sarcophagi, show architectural features designed to prevent tomb robbery, and are associated with mortuary temples and causeway structures typical of royal burial complexes. The pyramid texts inscribed in later pyramids explicitly describe their function as facilitating the pharaoh's journey to the afterlife. Treating the pyramids as anything other than tombs ignores this extensive evidence and requires proposing alternative functions for which no evidence exists. Fourth, technical feasibility. Experimental archaeology has demonstrated that ancient Egyptians could accomplish every aspect of pyramid construction using available tools and techniques. Researchers have successfully quarried, transported, and erected multi-ton stone blocks using copper tools, wooden sledges, sand ramps, and lever systems. While scaling these experimental results to explain moving millions of blocks requires extrapolating from small-scale demonstrations to massive projects, no fundamental impossibility has been identified. The ancient Egyptians simply devoted extraordinary resources and labor over extended periods to achieve extraordinary results. Fifth, no evidence for advanced predecessors. Despite over a century of intensive archaeological investigation in Egypt, no evidence has been found for an advanced civilization predating conventional Egyptian civilization around 3100 BCE. Survey of the Nile Valley, excavation of hundreds of sites, analysis of tens of thousands of artifacts, all consistently show gradual development from Paleolithic hunter-gatherers through Neolithic farming communities to the establishment of the First Dynasty. Sophisticated metalworking, writing, monumental architecture all emerge in sequence, showing clear developmental progression with no gaps suggesting lost knowledge or vanished civilizations. Sixth, dating consistency. Despite alternative claims, multiple independent dating methods generally agree on 4th Dynasty construction. Radiocarbon dates, while sometimes problematic, cluster around the expected period when systematic contamination is ruled out and old wood effects are considered. Historical records, though later, consistently attribute the pyramids to specific pharaohs. The astronomical alignments work for 2500 BCE, not requiring other dates. The entire archaeological context, pottery styles, burial practices, writing styles, administrative documents, consistently dates to the early Old Kingdom. The orthodox response to water erosion claims focuses on alternative explanations for weathering patterns, chemical processes, moisture wicking, differential hardness in limestone layers, and notes that accepting Schoch's interpretation requires rejecting the entire chronological framework of Egyptian archaeology based on a single disputed geological observation. The response to astronomical claims argues that finding alignments with ancient structures is inevitable, given the number of bright stars, and that proposed earlier dates are selected to match predetermined conclusions rather than derived from objective evidence. The response to claims about encoded mathematical knowledge is that the ratios of pi and phi appear naturally when building with certain geometric proportions and do not require conscious mathematical understanding to produce. A pyramid built to aesthetic proportions happens to encode these ratios because those ratios are fundamental to geometric forms, not because builders deliberately calculated them. The response to knowledge inheritance claims is that ancient peoples were as intelligent as moderns, had generations to accumulate astronomical observations and empirical understanding, and could achieve sophisticated results through patient observation and trial and error refinement without needing to inherit knowledge from hypothetical predecessors. The orthodox position is that while some details of pyramid construction remain uncertain, exactly which ramp designs were used, precisely how the largest stones were lifted, which specific tools accomplished particular tasks, the overall explanation is sound, evidence-based, and requires no extraordinary assumptions. The pyramids are remarkable, not because they are impossible, but because they demonstrate what humans can achieve through organization, patience, and dedication, applied over sufficient time with adequate resources. This is a strong position backed by extensive evidence. But it is not without problems. The sudden appearance of maximum sophistication at Giza, the lack of clear evidence for the massive ramps that should have been necessary, the precision that exceeds later Egyptian construction, the mathematical relationships that appear too consistent to be accidental, the global pattern of similar megalithic construction appearing around the end of the Ice Age, these remain troubling even within orthodox frameworks. Whether they are troubling enough to warrant reconsidering fundamental assumptions about human prehistory is the question on which mainstream and alternative researchers continue to disagree. The inheritance hypothesis. If evidence suggests the pyramid builders possess knowledge that conventional development cannot explain, and if flood myths worldwide describe earlier civilizations possessing advanced knowledge that was transmitted to survivors, then a testable hypothesis emerges. The pyramids represent the application of inherited knowledge. Knowledge preserved across the catastrophic boundary that separated the pre-flood world from the post-flood world. This hypothesis makes specific predictions about what evidence should exist. First, the knowledge should appear suddenly and fully formed in the archaeological record, without extended developmental periods showing gradual discovery. This is exactly what we observe. The pyramids represent maximum precision and sophistication in Egyptian architecture, built at the beginning of monumental construction rather than as the culmination of centuries of refinement. Second, the knowledge should be imperfectly applied, showing characteristics of inheritance rather than deep understanding. When knowledge is inherited without complete comprehension of underlying principles, application tends to be conservative rigid, and prone to degradation over time as transmission loses information. This matches pyramid evidence. The extreme precision coexists with apparent inefficiencies and oddities, like internal chamber design, that suggest builders were following patterns or instructions they didn't fully understand, rather than designing from first principles. Third, knowledge should degrade over time rather than improving. If indigenous development drives construction, later buildings should show increased sophistication as experience accumulates. But later, Egyptian pyramids show decreased precision, cruder construction, and clear evidence of cost-cutting and corners being cut exactly what knowledge loss through imperfect transmission would produce. The peak sophistication at the beginning, rather than the end, is characteristic of inheritance rather than development. Fourth, explicit traditions should exist describing inheritance from earlier sources. Egyptian texts consistently describe knowledge coming from the gods, from mythological past, from first time, when gods walked the earth and established civilization. While Orthodox Egyptology interprets these as purely mythological statements with no historical content, inheritance hypothesis suggests they might preserve accurate traditions about knowledge origin, expressed in religious language appropriate to ancient worldview. Fifth, astronomical alignments should point to epochs earlier than construction date, marking the period when the inherited knowledge originated. The 10,500 BCE correlation with Orion and Leo constellations, while controversial, matches this prediction if pyramids were built around 2,500 BCE, but designed using astronomical observations from 8,000 years earlier. The structure should encode information about both periods. Sixth, similar patterns should exist worldwide wherever survivors of the catastrophe established new civilizations. The global distribution of megalithic construction, precise stone fitting, astronomical alignments, and flood myths, all occurring in the same post-flood period, supports this prediction. If each site represents independent development, the convergence is remarkable. If all represent inheritance from a common source, convergence is expected. The inheritance hypothesis is consistent with known evidence and explains anomalies that orthodox explanations struggle with. But it requires accepting that advanced civilization existed before conventional archaeology recognizes that this civilization possessed sophisticated knowledge which it transmitted across the catastrophic boundary, and that survivors, or their descendants, built the pyramids and similar structures worldwide as expressions of this inherited knowledge. The hypothesis is not proven. No definitive evidence exists that would force acceptance by skeptical mainstream scholars. No artifacts clearly predating established civilizations and demonstrating advanced technology have been found, or at least none that mainstream archaeology accepts as such. No written records describe technical details of this inheritance in explicit terms that remove interpretive ambiguity. No physical remains of pre-flood cities have been excavated on now submerged continental shelves, though this is largely because underwater archaeology at required depths is expensive and technically challenging. But absence of definitive proof is not proof of absence. The archaeological record of human activity before 10,000 years ago is extremely fragmentary, biased towards sites that were not destroyed by flooding and that happen to have been discovered. Vast regions, coastal areas now underwater, deserts that were once fertile, regions covered by centuries of sediment, remain largely unexplored. The possibility remains that evidence for advanced pre-flood civilization exists but has not yet been found, has been found, but not recognized, or has been destroyed by the very catastrophe that necessitated knowledge transmission to survivors. What the inheritance hypothesis offers is a framework for understanding the pyramids that takes both mainstream evidence and anomalous observations seriously. It accepts that the pyramids were built around 2500 BCE by early Egyptians using available tools and tremendous labor. But it suggests this construction was guided by knowledge inherited from earlier sources, that the precision and sophistication reflect not indigenous development, but application of transmitted understanding, and that the pyramids serve not just as tombs, but as monuments to knowledge preserved across catastrophe, as markers ensuring that even if civilization fell again, future investigators would recognize that advanced culture existed deep in the past, and that knowledge, once achieved, must not be lost. The memory in stone. Whether the pyramids prove that a civilization survived the great floods may ultimately be unanswerable with available evidence. What is demonstrable is that the pyramids embody knowledge of astronomy, mathematics, geodesy, and engineering that is sophisticated enough to have required extensive development, yet appears suddenly enough in the archaeological record to raise questions about where it came from. The orthodox answer is that the knowledge was indigenous, developed over centuries of observation and practice that left limited archaeological traces because much was transmitted orally and because wooden tools, papyrus records, and other perishable materials have not survived. This is plausible and consistent with substantial evidence showing developmental progression in Egyptian architecture and culture. The alternative answer is that the knowledge was inherited, preserved from an earlier civilization destroyed by catastrophe, and transmitted to post-flood survivors who rebuilt civilization, incorporating what they could preserve from what was lost. This is speculative but consistent with anomalous evidence of sudden sophistication, with global flood myths describing exactly this scenario, and with the pattern of maximum early achievement followed by degradation. The truth likely incorporates elements of both explanations. Perhaps the early Egyptians were developing their own astronomical and architectural knowledge through indigenous observation and experimentation. Perhaps they also encountered remnants of earlier cultures, whether Saharan populations displaced by desertification, Mediterranean refugees fleeing sea level rise, or Near Eastern groups migrating from disrupted homelands who brought knowledge preserved from pre-catastrophic periods. Perhaps Egyptian achievement represents the synthesis of indigenous development with inherited wisdom, producing the remarkable civilization that built the pyramids and that continues to fascinate millennia after its decline. What the pyramids preserve, regardless of knowledge origin, is the principle that information can be encoded in stone, that knowledge can survive millennia if properly expressed, and that architecture can serve functions beyond housing or worship. The pyramids stand as monuments to human capability, to the drive to build lasting works, to the desire to be remembered and understood by distant descendants. Whether they also stand as monuments to knowledge rescued from catastrophe, to civilization that preceded what we recognize as the first civilizations, to survivors who ensured their ancestors would not be forgotten, that remains one of history's most compelling mysteries. The questions the pyramids raise about human prehistory, about what civilizations might have existed before writing and cities and agriculture appeared, about whether human development has been linear or cyclical, about whether knowledge once gained can be lost and must be painfully rediscovered. These questions extend far beyond Egyptology and touch fundamental assumptions about who we are as a species and how we got here. The pyramids will stand for centuries more, perhaps millennia, if they are maintained or if no catastrophe destroys them. Future generations, with better tools, better data, better understanding of ancient cultures and catastrophic climate change, will examine the same evidence we see today. Perhaps they will reach definitive conclusions about pyramid construction, dating, and the origins of the knowledge they embody. Perhaps not. But the pyramids will remain silent, massive, precise, enigmatic, continuing to pose questions about human history that refuse easy answers and that challenge every generation to reconsider what it thinks it knows about the past. The great floods described in myths worldwide definitely occurred. Geological evidence makes this clear. Catastrophic climate change, dramatic sea level rise, and the inundation of vast inhabited regions did happen at the end of the Ice Age. Whether civilizations sophisticated enough to produce the knowledge encoded in the pyramids existed before these floods, whether survivors transmitted this knowledge forward, whether the pyramids stand as evidence of inheritance from pre-flood predecessors, these questions remain open. The evidence is ambiguous enough to permit multiple interpretations, controversial enough to generate passionate debate, and significant enough that resolving the questions one way or another would fundamentally alter our understanding of human history. Do the pyramids prove a civilization survived the great floods? They do not prove it. Conclusively, no smoking gun exists that would force mainstream acceptance. But they are consistent with such survival. They preserve knowledge that has no adequate conventional explanation, and they stand as enduring monuments to the possibility that human history is longer, more complex, and more mysterious than standard narratives acknowledge. Whether that possibility represents reality or merely intriguing speculation is the question that continues to drive investigation, and that the pyramids, silent and eternal, decline to answer definitively. The construction mystery that won't disappear. Beyond the debates over dating and knowledge inheritance, the practical question of how the pyramids were actually constructed continues to generate controversy. Despite over a century of research, experimentation, and theorizing, no consensus exists on the specific techniques used to build the Great Pyramid, and the gaps in our understanding remain significant enough that alternative explanations continue to find receptive audiences. The fundamental challenge is the scale combined with precision, moving 2.3 million blocks, each averaging 2.5 tons, from quarries to the pyramid site, then lifting them to heights of nearly 500 feet and positioning them with tolerances measured in fractions of inches, represents a logistical achievement that strains credibility even with modern equipment. The largest stones, the granite beams forming the King's Chamber roof, weigh 70 tons each and sit 150 feet above ground level, positioned with precision that prevented any settling or cracking over 4,500 years. No ancient description exists of how this was accomplished. The ramp theory, most commonly invoked by orthodox Egyptology, proposes that earthen or brick ramps were built alongside or spiraling around the pyramid, allowing workers to drag stones upward as construction progressed. But the mathematics of this explanation are problematic. A straight ramp reaching the pyramid's apex, with slope gentle enough to drag heavy stones, would extend over a mile and would require more material than the pyramid itself. A spiral ramp wrapping around the pyramid faces problems with corner turns. How would crews maneuver multi-ton blocks around 90-degree corners on narrow ramps? Internal ramp theories propose that ramps were built inside the pyramid structure, using space that was later filled with blocks. But this requires leaving enormous voids during construction, raises questions about structural stability, and still does not explain how the heaviest stones reached the highest positions, since internal ramps could not have supported 70-ton loads. No definitive evidence exists for any ramp design. Some sand and brick debris has been found at pyramid sites that might represent ramp remains, but nothing sufficient to confirm the massive ramps that would have been necessary. The absence of substantial ramp evidence is puzzling because ramps would have required enormous quantities of material and considerable time to build and later dismantle, leaving archaeological traces that should be obvious. Alternative ramp designs, zigzagging external ramps, multiple shorter ramps, counterweight systems have been proposed, each solving some problems while creating others. The fact that after a century of debate no consensus has emerged suggests that either the evidence has been lost, ramps were systematically dismantled, and material reused, leaving no trace, or that construction methods remain fundamentally misunderstood. The tool problem compounds the mystery. Copper was the primary metal available to 4th Dynasty Egyptians, and copper tools have been found at pyramid sites. But copper is soft, far softer than granite or even than limestone. Experimental archaeology has shown that copper chisels can cut limestone through persistent pounding and the use of quartz sand as an abrasive, but the process is extremely slow and requires frequent sharpening or replacement of tools. Extrapolating from experimental rates to the millions of blocks needed for the pyramids suggests tool requirements and construction times that strain plausibility. For granite, much harder than limestone, copper tools are even less effective. Some researchers have proposed that the Egyptians used iron tools despite no iron artifacts being found from this period, or that they possessed bronze before the Bronze Age officially began in Egypt, or that they used stone-on-stone pounding techniques requiring no metal tools at all. Each explanation addresses some evidence while conflicting with other evidence, and none fully resolves the tool problem. Precision presents additional challenges. The blocks are not just roughly shaped, but precisely finished, with flat surfaces and right angles, accurate enough that joints between blocks are too tight for paper. Achieving this precision with hand tools would require not just patient labor, but sophisticated techniques for measuring, checking, and correcting, none of which are clearly documented in Egyptian records or artifacts from the Pyramid Age. The absence of mistakes is equally puzzling. Modern construction projects, even with computer-aided design, laser measurement, and precision machinery, routinely produce errors that must be corrected. Yet the Great Pyramid shows essentially no errors, no blocks misaligned significantly, no passages that had to be abandoned due to calculation mistakes, no evidence of major design changes during construction. This suggests either that the builders worked from extraordinarily detailed plans that anticipated every challenge, or that trial and error occurred elsewhere in ways that left no surviving record. Some alternative researchers have proposed that the pyramids required technology beyond what conventional archaeology attributes to ancient Egyptians. Suggestions have included acoustic levitation, using sound waves, no physical evidence, speculative physics, chemical softening of stone, allowing it to be molded, no evidence of appropriate chemicals or their residues, geopolymer concrete poured into molds rather than carved blocks, disputed interpretations of microscopic analysis. and knowledge of machines or techniques later lost, absence of any mechanical remains or clear descriptions. These alternative technology theories are rejected by mainstream archaeology as speculation unsupported by evidence and unnecessary to explain construction when sufficient manpower, time, and clever use of simple machines can account for results. But their persistence reflects genuine unsolved problems. The pyramids were built somehow, the precision exists and must be explained, and the gap between what we know the Egyptians could definitely do and what the pyramids demonstrate they did do remains larger than conventional explanations comfortably accommodate. The construction mystery matters for the question of flood survivors and knowledge inheritance, because it touches the issue of how sophisticated the pyramid builders actually were. If construction required only what orthodox archaeology attributes to early Egyptians' patient labor, with simple tools, clever problem solving, good organization, then indigenous development is sufficient explanation. But if construction required knowledge or capabilities that significantly exceed what 4th Dynasty Egypt should have possessed, then inheritance from more advanced predecessors becomes more plausible. Whether the construction techniques will ever be definitively determined is uncertain. Without contemporary records explicitly describing methods, without preserved examples of the tools and machines actually used, and without the ability to observe ancient construction in progress, all explanations remain partly speculative. The pyramids stand as accomplished facts whose methods remain partially mysterious, continuing to generate theories, experiments, and debates that reflect both the limits of archaeological evidence and the endurance of structures that refuse to yield all their secrets. The Survivor's Testament. If the inheritance hypothesis has merit, if the pyramids do preserve knowledge from pre-flood civilization, then we might ask, why? Why would survivors of catastrophe invest enormous resources in building monuments, encoding astronomical and mathematical information? What purpose would such structures serve? One possibility is memorialization. The survivors wanted to ensure that knowledge of their predecessors, of what had been achieved and what had been lost, would not vanish entirely. Oral traditions fade, written records perish, but massive stone structures endure. By encoding knowledge in the proportions, alignments, and dimensions of the pyramids, survivors could create a monument that would outlast languages, writing systems, and cultural traditions, preserving information in the universal language of geometry and astronomy. This would explain why the pyramids encode multiple kinds of knowledge, not just religious beliefs about the afterlife, but mathematical constants, geodetic information, astronomical alignments spanning thousands of years. They function as time capsules, as encrypted messages to the future, as demonstrations that advanced knowledge existed, and that whoever built these monuments understood principles that later generations would rediscover only through centuries of scientific development. This interpretation gives purpose to features that seem oddly unnecessary. For tombs, the precise alignment to true north, the encoding of pi and phi, the Orion correlation, the positioning at the center of Earth's landmass. If the pyramids were only tombs, these features serve no function. But if they were also monuments to lost knowledge, demonstrations of pre-catastrophe sophistication, then every precise measurement, every mathematical relationship, every astronomical alignment serves the purpose of communicating across millennia to future investigators capable of recognizing significance. The decision to build in stone rather than more practical materials supports this interpretation. stone lasts. Mud, brick, wood, and other materials decay. If the goal was functional architecture palaces, cities, workshops, then stone would be unnecessary expenditure. But if the goal was creating monuments that would survive indefinitely, stone was the only choice. The Egyptians built their houses and palaces of mud brick, only temples and tombs were stone. This suggests they understood permanence differently depending on purpose. Utilitarian structures could be temporary, but sacred structures needed to endure. The positioning on the Giza plateau is also suggestive. The plateau is geologically stable, elevated above the Nile floodplain, visible for miles. If the goal was simply royal burial, many locations would have served equally well. But if the goal was creating monuments that would remain visible and intact for millennia, the plateau was ideal choice. The bedrock provides stable foundation. The elevation protects from flooding. The location ensures visibility. Another possible purpose is astronomical. The pyramids might have functioned as observatories, as instruments for tracking celestial movements and maintaining calendars. The precise alignments, the air shafts pointing to specific stars, the Orion correlation, all support this interpretation. Societies dependent on agriculture needed accurate calendars to know when to plant and harvest. Flood-based agriculture, like Egypt's, required predicting Nile floods, which ancient Egyptians correlated with the heliacal rising of the star Sirius. The pyramids could have served to maintain and transmit this knowledge across generations, ensuring that astronomical understanding survived even if the society that developed it did not. This astronomical function would make the pyramids not merely monuments to the past, but tools for the future infrastructure, ensuring that essential knowledge for agricultural survival would be preserved and accessible. The encoding of precessional information, if confirmed, would serve similar purpose, maintaining awareness of the slow changes in celestial positions over centuries and millennia, allowing future astronomers to recognize that their ancestors understood these cycles and had achieved sophisticated astronomical knowledge. A third possible purpose is mythological or religious. The pyramids as anchors for cosmological beliefs, as physical manifestations of creation myths, as structures maintaining cosmic order through their existence and proper maintenance. The pyramid form itself, rising to a point that touches the sky, represents connection between earth and heaven, between human and divine realms. The precise east-west alignment represents the sun's daily journey, the cycle of death and rebirth. The Orion correlation connects the earthly pyramid with stellar realm where the dead would dwell. In this interpretation, the pyramids function as axis mundi, as points connecting multiple realms of existence, maintaining order through their presence and proper ritual. If flood survivors believed catastrophe resulted from cosmic disorder, from breakdown in proper relationships between earth and heaven, then rebuilding these connecting structures would be religious imperative as important as physical survival. The precision would be necessary, not for practical reasons, but for ritual ones. The pyramids must be perfect to serve their function of maintaining cosmic order. These interpretations are not mutually exclusive. The pyramids could simultaneously serve as tombs, monuments, observatories, religious structures, and encoded messages to the future. Multifunctionality is characteristic of sacred architecture across cultures. Gothic cathedrals were simultaneously churches, community gathering spaces, astronomical calendars, and demonstrations of theological principles in stone. The pyramids likely served multiple purposes, some explicitly understood by their builders, and others perhaps operating at symbolic or unconscious levels. What the inheritance hypothesis adds to these interpretations is temporal depth. The suggestion that the purposes served and the knowledge encoded stretch backward through the catastrophic boundary, connecting post-flood civilization to pre-flood predecessors, ensuring that even if most of what was lost could not be recovered, some essential knowledge would survive. In this reading, the pyramids are not just monuments of early Egyptian civilization, but monuments of human civilization writ large, testaments to the possibility that we have been here before, that knowledge has been achieved and lost and painstakingly rebuilt, that catastrophe need not mean permanent end if survivors have will and wisdom to preserve what matters most. The legacy of questions. Ultimately, the pyramid's greatest legacy may be the questions they continue to generate. For over 2 centuries, investigators have measured, excavated, theorized, and debated, yet fundamental aspects of these structures remain mysterious. This persistence of mystery is itself significant. It suggests that either our understanding of ancient capabilities is incomplete, or that the pyramids embody complexities we have not yet fully recognized. The questions touch every discipline. For archaeology, how do we date structures when multiple lines of evidence provide contradictory results? For geology, how do we interpret weathering patterns that don't match conventional chronologies? For astronomy, what does it mean when structures align with celestial configurations from epochs thousands of years before conventional construction dates? For engineering, how were construction feats achieved that strain explanation even with assumed ancient techniques? For anthropology, what does it tell us about human development if sophisticated achievements appear suddenly rather than through gradual progression? These questions resist easy resolution because they challenge assumptions built into each discipline's methodology. Archaeology assumes stratigraphy and artifact typology provide reliable dating. Geology assumes weathering rates and patterns follow consistent rules. Astronomy assumes ancient structures reflect contemporary sky conditions. Engineering assumes available technology constrains achievable precision. Anthropology assumes cultural development follows generally linear trajectories. When evidence from the pyramids conflicts with these assumptions, debate becomes not just about interpreting evidence, but about which assumptions take precedence. The broader significance extends beyond Egyptology to questions about human history and prehistory. If the pyramids preserve inherited knowledge from earlier civilizations, it implies human development has been neither linear nor irreversible, that societies can achieve high levels of sophistication and then lose that sophistication through catastrophe or collapse, requiring survivors to rebuild. This cyclical view of history contradicts the progressive narrative dominant in Western thought since the Enlightenment, where human societies are assumed to develop from simple to complex, with setbacks being temporary. The flood component adds another dimension, the possibility that environmental catastrophe has repeatedly disrupted human civilization, that the end of the Ice Age was not merely backdrop to human development, but active force shaping it through destruction and displacement. This shifts focus from human agency to environmental constraints, suggesting that climate and geography have played larger roles in determining the course of civilization than standard narratives acknowledge. For those seeking to understand the pyramids, the inheritance hypothesis offers explanatory power while creating new difficulties. It explains anomalous precision, sudden sophistication, mathematical knowledge, and astronomical alignments by attributing them to transmitted information from earlier sources. But it requires accepting that advanced civilization existed before archaeology recognizes any, that this civilization possessed knowledge conventional development timelines suggest should not have existed, and that transmission mechanisms operated to preserve this knowledge across catastrophic discontinuity. Mainstream archaeology rejects these requirements as unnecessary and unsupported, maintaining that conventional explanations, while incomplete, are adequate given available evidence. The debate will likely continue for generations. New evidence from underwater archaeology, exploring submerged coastal sites, from improved dating techniques, from advanced analysis of weathering and construction, may eventually resolve questions definitively. Or it may simply refine debates without providing conclusive answers. The pyramids themselves will endure, patient witnesses to human curiosity, standing as they have for millennia, preserving whatever secrets their builders encoded in stone, awaiting whatever future understanding humanity achieves. Do the pyramids prove a civilization survived the great floods? Perhaps the more important question is what it would mean if they did. It would mean human history is longer and more complex than we assume, that knowledge can be lost as well as gained, that civilization is fragile, and that what we achieve can be destroyed by forces beyond our control. It would mean that monuments built to outlast catastrophe did their job, preserving information across the millennia, waiting for descendants capable of recognizing and decoding their messages. And it would mean that the ancient flood myths, dismissed as primitive mythology, might preserve accurate memories of real events, catastrophic flooding that destroyed earlier worlds and required survivors to rebuild civilization with whatever fragments of knowledge they could salvage. Whether this scenario is true or merely compelling speculation, the pyramids stand as evidence that our ancestors, however ancient, were capable of extraordinary achievements, that they sought to build works that would outlast their civilizations, and that they succeeded in creating mysteries that continue to challenge and inspire millennia after the civilization that built them fell into history and then into legend. The pyramids endure, magnificent and enigmatic, continuing to pose questions that each generation must answer for itself about who built them, how, when, why, and what knowledge they preserve from the depths of time.